Hello, this is Physics 103. This is on nuclear physics, and in this lesson we are going to learn about nuclear reactions. So we have talked about radioactive decay, and we have learned about alpha decay, beta decay, and gamma decay. So for these processes to occur, nothing needs to be done for them to initiate. In other words, they can happen naturally or they can happen spontaneously. So for nuclear reactions, you need to have to initiate the process. So one way to start a nuclear reaction is to bombard a nucleus by particles. For example, here in 1919, Rutherford experimented with the nucleus of a nitrogen atom. So he sent alpha particles to be bombarded into the nucleus of a nitrogen atom, and he observed that there's the nucleus of the nitrogen atom changed into an oxygen atom plus one proton. So you need, for nuclear reactions to happen, you need to have something to bombard a nucleus to start a reaction. So nuclear reactions must obey some conservation laws. Particularly, it should follow conservation of charge, momentum, energy, and we are going to add another conservation law, which is conservation of nuclear number. So as an example here, conservation of charge in this reaction is seen by the atomic number of the alpha particle. So it has a positive 2 charge and it has 7 here. So this is the before value of the atomic number is 9. So you have 9 protons. And then after the reaction, oxygen has 8 protons and you have 1 neutron. So charge should be conserved. And as for energy, we will talk about that later. So in general, nuclear reactions are not elastic collisions, meaning kinetic energy is not conserved. So some of the kinetic energy is, actually most of the kinetic energy is converted into heat during the process. So it's not an elastic collision. And more importantly, we know that in nuclear reactions, or in nuclear processes in particular, the total initial mass is not always equal to the total final mass. So some of the mass is converted to energy, and vice versa. If you want to combine, say, some nucleus, you need energy. You need binding energy to be converted into mass. So this equation is it stems from Einstein's equation, E equals mc squared. So as an example here, so we are going to solve an unknown byproduct of this nuclear reaction. So you have an alpha particle to be bombarded to an aluminum nuclei. So there's a product, an unknown product with atomic number Z and mass number A. think this should be A and then Z plus 1 neutron. So by conservation of charge, before the reaction we have 2 protons from the alpha particle plus 13 protons from the aluminum nuclei. So after the process, since this is a neutron, so it has 0 charge, so this should have 15. So we know that at the number of protons is 15, and since there's a 0 neutron here plus 0 charge, for the number of nucleons we have 4 plus 27. So after the reaction we should have Z equals so 4 plus 27 is 31, and since we have another neutron, we have 30 plus 1 from this neutron, so our Z should be 30. So our unknown element should have mass number of 30, and an atomic number of 15. So this element is phosphorus. So that is nuclear. That's how you solve a nuclear reaction.